in general. Not first year practicals have not started. DNS is going to start. They are in quarantine, and then third years are in quarantine, and so it is going to be a cyclic, So every day there will be practicals. Hello. Huh? Huh? कुठून? कशाच्या? नाही नाही, आता मला इंटरेस्ट नाही आहे, पण आता मी बिझी सुद्धा आहे. ठीक आहे. थँक्यू. शुअर शुअर. Sorry, somebody is trying to sell me land. Okay. Okay, let's go on.
Sir, why don't we got a call like this?
Why? April, I do guesswork right now. Okay, Omar, it's not, nobody can really guarantee you when. Here, what is the idea is to get rid of practical, so something we keep on moving so that there will not be excessive load on you and you still finish your course in required time, not extending it and stretching you in additional 6 months. So that is not the right thing, no? Okay. What you said, where you don't get calls like this, you will get many more. Okay. Okay. Okay, let's start. Now, geographical features always affect shipping because, after all, what is ship? Ship is something floating in the ocean. We get bad weathers in ocean, storms, strong winds, big waves, so on. If you want to see scary side, go on YouTube. You will find big waves, how they break on ships, and so on. Then the worldwide temperatures vary. You go to extreme north in winters like Norway, you may find minus 22 degrees Celsius. If you go to Norway in summers, you may find it nice 25 degrees, 30 degrees, up 25 normally. Now, you sail from, say, Norway with plus 25 and you go to Argentina, one of the southernmost ports. You may find temperatures is minus 10. So, there are temperatures which will be affecting you. There is wind, weather, storms, they will be affecting you. Other ones, like if you go to, say, Norway during Norwegian summer on the longest day, for example, okay, in the northern hemisphere, that is around, I think, 23rd of June. There is no sunset. That's what they say, midnight sun. People go there as tourists in Norway. So I have been there like that. That there is no night only. And when you think the sun has gone down, you still have bright twilight, and you can, day and night, you can read newspaper on the street. Now, that sort of thing also affects. And I have been other way around, when sun used to rise around 10:30 in the morning and used to go down by 1 o'clock. Yeah, I have seen some. Say, you can see it. It's your luck. When you go there, if conditions are right, you see it. Not there, there's nothing you can do. But you get all these situations here. Okay. Then there are like time zones, like countries follow time zones, so the time keeps on changing, so you keep on adjusting your clock because your ship is going in that time zone. Then, as usual, you get rains, snow, all sorts, sandstorms. You get sandstorms also. Okay. I had a sandstorm right when we were transiting Suez Canal. I was that time second officer, I think. I think I was second officer. But you get all sorts of things. Now, let us start moving from one point to other. What is climate? Climate is statistics of weather over long period of time. Means climate is not one day reading it. Today is cold, so that is not climate. That is weather. When you do observation of weather for say 1 month, 2 months, then you say taking that average, taking that statistics, you will say, yeah, the climate is cold there in this month. Why? Because this month's observations are there, and we are taking whole month as a general thing. We are not taking daily weather. So that is a major difference. What is climate and what is weather? Weather is a short-term condition. That means weather today is stormy. Fine. That means only for today. Climate is we are talking about a month. In this month, climate is cold. In this month, Delhi gets fog. Why? Because those are the climatic conditions. Weather is one day you may have fog, next day you may not have, but then you are taking the observations of 1 month, and when you realize 20 days there is fog, 25 days, so there is a climate is foggy. Like that. Clear? Hmm? Clear or no? Okay. Now, climate system is something which is what fire component, five components, and all atmosphere, hydrosphere, psychrosphere, and so on. Okay. Don't ask me too many details about it because I can't explain them. But these are different impacts you get. It is not necessarily at certain latitude weather is same all over the world. No, there are other factors which affect. There are places where the climate is always cold, regardless of summer, winter, rainy, anything. Then there are other way around, always hot. Then those are local effects, and there are many things. So it is affected. One thing is latitude because the sun's declination changes and according to the heat is received. So that is one thing. Latitude, terrain, altitude. If you go to Himalayas, it will be high altitude. Correct. So height is going to affect the temperature. Then there are water bodies. Water bodies means like sea. See, at sea the climate doesn't vary too much relatively. Over the land it changes a lot. Why? Because the ocean don't get heated up like land or don't get cooled down either. So relatively they remain similar temperatures. Now in that you have got currents. Currents have got different temperature than the surrounding water. One important thing always remember current's temperature is little different than the surrounding water. Small differences, but there are differences. So what we do is we generally classify climate according to what some variable means, but mainly what we use generally. Climate is hot or cold means something to do with temperature. And another one is precipitation. Now fog also comes in precipitation. Precipitation is rain. So this is rainy season. Like we say that climate is rainy or temperature. These are the main ones we use. So in a typical narrow sense, it is average weather. That is climate. Now, World Meteorological Organization, they define it after observing it for 30 years. And now it is improving because there are more weather observatories. The gadgets are all over, which are reporting the temperatures, it's reporting humidity, it is reporting precipitation, and so on. So the readings are much more accurate today when you look at it. Our Google weather also gives us very good indicator of what is going to happen today afternoon at 4 o'clock. Correct? That is how more and more weather observations are coming in, and supercomputers are maintaining the track, and then they are doing prediction. It is something else. But we know what is the climate in certain months, certain time of the year. What is the climate? Now, how does it affect us? Oh, you are going to the cold climate, so you have to prepare ship accordingly. Means, for example, ship is going to cold climate. So first you will check everybody has got proper warm clothes or no. Then we also check what stores we need. Fuel oil, because you will be burning extra fuel oil for heating up. So do you have it? And so on. We work out. Like for example, if ship is going to go to say Norway in winters. Norway I'm using more and more because I have been there. You can say Russia is next to it also. It's no problem. What we expect, there will be a lot of ice. Yes, that is correct. Winter load lines, but they have got nothing to do with our chapter. Okay. Right now, let's concentrate on how the climate is affecting. So you have to prepare the ship. Now, what happens is, if I'm going to go to very cold climate, I expect ice accretion on deck. That means collection of ice on deck. How do I get rid of it? Maybe I had to throw salt on it. So I must keep salt, and so on. Like then sometimes what happens? We use hydraulic oils for running the deck machinery. We may have to change the grade of hydraulic oil. Why? It will be excessively cold, and you need a hydraulic oil which will work at that specific temperature. So where do I get specific temperature? I get the information. Climate is like this. Expect temperatures of so much, and I do it. Okay. So this is the typical impact. Extra fuel oil may be needing, ice for preventing ice, warm clothes, hydraulic grade oil change. And normally ships are designed with all the things considered. The climates, various climates are considered. So impact is generally low. Unless you are really going to one of those difficult places like South Pole or something, the polar navigation you are going to do, then you will probably think differently. But average ships operate between 70 and 70, 70 north and 70 south. Those are the average ships. And towards the 70 age, if you are going to go that close, then generally you have got additional precautions taken. Sometimes you may be putting extra heaters to warm up this oil, hydraulic oils, and so on. Okay, the water temperatures don't change that much. Water temperatures vary. Sea has got minor variations. When you are in deep seas and all, your temperature variations are also fairly normal. Once you come to coastal areas, then the coast starts affecting you. Now, the most important one normally that affects shipping all the time is tides. Okay. Now, tides are what? Rise and fall, rise and fall of water level. The ones who live next to sea, many of you are living next to sea. You know what is high tide, what is low tide. The ones who don't live close to water body, the big water body, because the rivers and all the tides is too minute, so you don't notice it. So big water bodies, water will move, get pulled by the gravitational forces exerted by moon and sun and the rotation of the earth. All the thing forces get mixed up, and according to that the resultant force pulls that water. So water body moves. Now earth rotates in 24 hours. Normal tides. Now tides also get affected because it is like funneling. Water has to get funneled in creeks and all. That is where you observe. Deep oceans there are no tides, means you don't notice it also. It has got no impact on ships. But when you are in coastal areas, their water movement affects, and then there is a funneling effects. Why? Because you can go in fast but you can't come out fast, and like that. So there are delays and all. Otherwise the ideal cycle will be every 12 hours you will have say high water, and every 12 hours you will have low water. Means every 6 hours tides will change theoretically. However, because of the effects of the land and all, they vary anything between say 5.5 hours to 6.5 hours on average. Every place, what we do is we calculate height of tide based on predictions. Now it's always predicted. It is not perfectly what you say digital science. There will be small variations, error margins will be there, but it will never be without error margin. It will always be that you will study later on in tides in deep when you work out. Now, what happens with the tides? There is observation done for many years. Means there is a job. It used to be a job for a person. Today is probably automatic. You just put it and it is recording and sending it. So then you find the on one spot water going up, coming down, and then you will find how what rate it went up, what rate it came down, and you find some sort of a simple harmonic motion. And you are also maintaining what is happening with the sun and moon positions and all, and so that is how you observe it. You observe maybe 5 years. Then just a minute, I had to take this call. हेलो, बोलो. नहीं, मैं नहीं आ रहा है, बट बिकॉज मानसी बोली राजू इज ऑल्सो वो मैनेज करने वाले हैं. नहीं नहीं, मैं अभी इधर कॉलेज में हूँ. वी स्टार्टेड कॉलेज सॉर्ट ऑफ टीचिंग. तो मैं पूछा था तो ते बोला सब लोग जाने से ये नहीं. ओनली थिंग आई टोल्ड हर दैट तुम्हारा भी एक सर्वेयर रखो, सो दैट वो दूसरा सर्वेयर बदमाशगिरी नहीं करेगा. नहीं नहीं, दैट इज ओके, बट थोड़ा सा इधर उधर करते हैं लोग, एंड नोइंग बालू एंड ऑल. वो लेवलिंग करके लिया, उसमें तो पुराना बाउंड्रीज भी हटा दिया होगा. सो जरा सा मैं बोला था तो बोली ठीक है. हाँ तो देखेगा क्या है, एक बार निकल तो जाने दो सब. जा, बाकी ठीक. Sorry, all various things are coming in. Okay, so observations are taken over a long period, and then you synchronize and you start predicting the future. That means you have taken a 5 year cycle or something like that, and then based on the same positions of sun, moon, and all, you synchronize somewhere and you reset and start again. Then you start predicting. Now that prediction will be more or less okay. Now we also keep some safety margins so that we don't run into unexpected issues like running aground of the ship. Because no matter what happens, the heavenly bodies like sun, moon, and all, they also follow a pattern. Okay, like moon takes about just around 24 hours, not exactly, around 24 hours to go right round. Then there are something which you will be doing in navigation anyway. But right now remember, tide tables are made, tides are predicted. This is very important. You cannot calculate a tide. What we calculate in a tide is in between interpolation. That is what we say tide calculation, interpolation. But high water time and low water time is predicted. We take that. Now, then there are effects of variety of things, wind effect, atmospheric pressure effect, and also there will be small error margin. But then what we do, instead of touching the sea bottom, we start measuring it say 1 meter above. So whatever the variation will come, which will be there, and still the sea bottom will be clear. Something like that we do. Okay, if you remember that much is good. And remember, the tides happen in coastal regions and they affect the depth of the water. They affect the depth of the water. Now, chart is calculated on something, then whether it goes below the chart datum. Datum is the level which is taken to make the chart. Tides will add or subtract from that datum. Normally, it doesn't subtract because they ensure that most of the places in the world, there are places where it has got impact. Otherwise, that remains on top only, top of the chart datum. There are places where it goes below the chart datum. It is mentioned there, but depth of water changes. Depth of water changes means we have an issue with the draft of the ship. If my draft is 10 meters, I must have 10 meters water. Otherwise, I will be hitting the ground. That is why I check. Because depth at the berth is different, depth in the channel is different. So we keep track of the depth which is affected by high water, low water, and our ship's draft. There is also another issue when we measure the tides. If you're passing under a bridge, the highest point, we have seen the air draft. So the air draft gets affected. You realize one thing, the draft doesn't get affected with tides. Draft is your draft. Depth of the water gets affected by tides, and air draft gets affected because air draft is water level to the topmost point. Now, water level has gone up by 3 meters because of high water. So, the clearance what was given to me, somebody gave me clearance, okay, the clearance, overhead clearance is 30 meters. I checked it, yeah, 30 meters, I am 29.5, I will easily go through. That is at the zero level, okay. But I get high tide of 2 meters. Now, that 30-meter clearance which was given will become 28 meters. And if I am 29.5, my top is going to hit the bridge or the power cable. So, again I am repeating, tides affect depth of water, not draft of the ship. But tides affect air draft of the ship. Got it? Yes, no.
Yes, sir.
Yes, sir.
Very good. Very good. All these things you have to throw in parties. Huh? Tides and the clearance and how close and if there are some stories banane ko sikho. You learn some stories. Okay. Now this is a picture of what is low tide, water level is down, high tide, water level is up. It is the same thing, side by side it is shown. Now, tide are, we will be concerned about tides only when they start affecting us. That is why we are more worried about the ports because the depth of the water in the port is dependent on tide, height of the tide, what we say. Oceans, water is too deep, so we don't care. Things happen, water movement will be there, but it is not noticeable. Why? इतना deep में थोड़ा सा फर्क क्या पड़ता है. But when you are in ports, it affects a lot. Now, if lake is there, lake will have also some tide if you take a microscope or something and start looking at it. Water body size has to be certain things to make it interesting for us. That's why I said rivers and all you don't see. But when the rivers meet sea, that place you will always find the tides. Why? Because water can come in from ocean and fill it up. So they bring the salinity with it because seawater is salty, so it brings salt inside, then it takes it out, and it goes on. That is why if you see creeks which are next to sea, they are affected heavily. Now, When this water movement happens, like I have taken this much water and it has moved here. How will it move? It has to move. So it is going to move through the water only. But going from here to here, it is going to form some sort of a stream. Means from high level it is going to low level. Then it fills it up there, then it comes back. So those are to and fro streams, which are called tidal streams. Okay, the strength of tidal stream is based on how much the difference in height. Now, when water is filling up means the level is rising, we call it flood tide. The level is rising. And when it reaches the highest level, we say it is high tide. And time is so and so for high tide. That means time will be given 2:42 in the afternoon will be high tide and height of the tide will be so much. This is the information you get. So that is high tide. And when the water is going with high tide to increase the height of the water, you call it flood because it is flooding. Exactly opposite, after high tide, water is going to recede. So that time there is ebb tide. Okay, till it reaches low tide. Draft is draft is your depth underwater from the water line to the keel. Okay, bottommost part of the ship is your draft, which is based on the weight you are carrying, the load you are carrying on your ship. Air draft is maximum height of the ship minus the draft. Correct? Now what happens is, if this is it, say you can see this line. Now suppose this is the ship's water line. Fine. We know what is underneath. We know how much water depth we want. From here to here, okay, is air draft. Air draft is required to pass under the bridge or under the power cables or anything else on overhead stuff. Again and again, we are going back to the draft. Draft is the depth under the measured from the water line to the keel. Okay, that is the definition. Why are you asking again and again? We have already cleared that, isn't it? So, from ebbing, we say ebbing, that's a ebb tide. It goes down till it reaches low tide. So, when and then it starts back again. From low tide, it starts flood tide till it reaches high water. Now, the consecutive high waters need not be same at all in height. Height of tide changes. Then, additionally, what happens? Sometimes sun and moon are on same side. They may have angles. So when everything is on same side and pulling heavily, the fluctuation is lot. The lowest tide will go down, highest will high. This height will be lot bigger. If it is the case, we call it spring tide. That is where the difference between low tide and high tide is maximum. In a month, generally you get spring tides for a period of about 1 week in a month, and neap tides 1 week in a month. Now also remember one thing. What happens is from low tide, water starts flooding. It comes up to here. This is the flood tide. Then it starts ebbing, comes back here. Okay, that things might change little bit. But when it is right on top or right and bottom, there is no water movement because it has happened and you have reached the curve's bottom or top. Curve will be like simple harmonic motion type of curve. So you have reached the top point or bottom point. So that is the time you don't have tidal streams running. Tidal streams change the direction that time. So that is also called slack water or slack tide. Slack water means there is no stream affecting your movement in the water. It lasts for maybe 15 minutes, half an hour limit, and then it starts building up. In the middle of the time, it will be maximum. That means suppose there is high water at 12 o'clock and low water at 6 o'clock. 12 o'clock, there will be no streams. 6 o'clock, there will be no streams, so there will be slack water. And 3 o'clock in the afternoon, there will be strongest stream. So 3 o'clock say strongest stream going say east to west. Add 12 hours to it, that is 9 o'clock, it will be going west to east, opposite direction. Streams keep on cancelling each other all the time over a period. Okay, normally what happens is you get two high waters in 24 hours approximately and two low waters in 24 hours. Now sometimes because again what happens, it is strictly based on what is local topography. So water has to find a way, no? If it is like funneling effect, it is blocked. So not so much water can go in. So it will affect, it will not complete the cycle. By the time it tries to complete cycle, it turns back. So there are effects. But our concern is only one thing, what is the water depth available to me for my ship? That's my concern. And what time is high water, low water, and then there are today what happens is with the gadgets available, you are also monitoring the predictions. So if you find that some noticeable error is there, you can take the corrective action. And for ships, what generally is done is the channel is made. No, rolling pitching is never caused by the tides, those are tidal streams. Tidal streams are not that strong to create big waves. Big waves are formed only after there is a consistency in the direction of wind or something. Then the waves are formed. It is not that brief intervals. Okay? Okay. Now, our concern is depth of the water. Now, what happens very often, dredging means digging up into the sea to make a deep channel for the ship is expensive affair. So very often, what is done? I know that every day I have got on average 3 meters tide. Low water to high water is 3 meters average available because I got predictions. I know it. So what I do? My channel depth is say 12 meters standard and the normal conditions without adding any effect of the tide. So 12 meters ship I can bring anytime. Why? Because draft available is 12 meters. Now what happens is I want to bring a ship which is deeper than that in draft. So berth is there. Now berth is made deep. They say now we will make it deep because we can take the bigger ship. So berth depth is say 15 meters. Okay, berth depth. Channel depth is 12 meters. So what we do is we manipulate timings in such a way that ship goes over the 12 meters depth channel as a 15 meter because we use the height of tide, that 3 meters advantage we take. So a 15 meters draft ship at high waters crosses the channel and she goes alongside. Now berth is okay, berth is 15 meters deep, so there is no issue.
So can you please explain again, sir?
Yeah, okay. Now the channel which is there to bring the ships from the sea to the berth is made 12 meters deep. That means under normal conditions, if you don't consider tides, you can bring the ship with the draft of 12 meters. Now what happens is we want to maximize things. So I'm getting a ship with a draft of say 15 meters. So I check what is my height of tide. Means if high water, how much is the height? So I find say 4 meters extra I get because the high water is 4 meters above the normal height. So at that time, at that suppose 3 o'clock is my high water time. So at 3 o'clock, what will be the depth of the channel? 12 meters plus height of tide. Suppose it is 4 meters. That means at 3 o'clock, height a draft available or depth of the channel will be 12 plus 4 meters, 16 meters. That means if the depth available is 16 meters for a small time, I can bring the bigger ship in that time. Why? Because I got more depth available. I bring the bigger ship with a draft of 15 meters, take her alongside the berth. Berth is already deep. See, berth is after all how many meters? Maybe 300 meters, 400 meters. Digging that is not that expensive comparing to digging a channel which may be 10 kilometers long or more. It's very expensive. So what happened earlier days, we were always working on these tides. Today in India, for example, there is a port, Pipavav. That is where you got lions also in the port. Huh? They actually come walk in the port. So there, the outside sea level is I think about 13 or 14 meters. So what the berths they have made deep, and they take ships only when there is high water. High water means they add up, say 13 meters depth, and they add another say 3 meters, 16 meters. So they say okay, up to 16 meters we will take the ship in. But whole port runs on that idea, and to load those ships, we work on 2 months in advance. Means we work out the heights of the tide 2 months in advance, and then we plan out loading in. So is it clear now? Hmm.
Yes, sir.
Okay. Yes, sir. Very good. So now the impact of the tides are like this two ways. One is it is impacting your depth. Okay. So you want to do all the time at high water so that you are safe in the channel. And another impact that happens is like I told you, if it's 12 o'clock high water and 6 o'clock in the evening low water, 3 o'clock the tidal streams. Tidal streams are something like a local current. But the difference in stream is and current is current goes one way. Streams they change direction every 6 hours. 6 hours this way, 6 hours this way. So tidal streams can be very strong in certain areas, which make it very difficult to berth the ship because believe me, everybody wants more and more. In the end, the what I will say maneuvering of a ship, or in crude language, driving of a ship is not that easy with all the forces pulling, pushing, and all. So, if you don't have strong tugs available, your judgment goes wrong, you can play havoc with the port. So, most of the ports for very big ships they do it only at high water when there is no tidal stream. That is called slack water. We covered it up early. So, that is slack water. So there are two impacts. One is the tidal stream impact, other one height of the tide. Two impacts are on the ship. Got it? Yes, no. Hmm? Yes or no? Yes. Okay. Everybody yes sir? Or some are still no sir? Huh?
No, sir.
No sir means you are okay or you have some questions.
I wanted it to be repeated, sir.
What do you want it to be repeated? What exactly?
Impact on ships.
Impact on the ships is in two ways. One is our draft is our primary consideration, right? So our draft is whatever is the draft, the water depth has to be more than the ship's draft. So the channel depth may not be sufficient. So we work it out with the timing, what time there will be extra water in the channel. So you have got extra depth available. So that extra depth we utilize it to go alongside. That means what happens is our timings are restricted when we can go to port. It is not any time you walk in. You have to wait for a specific time and then you go in the port. So that has got something to do with the depth of the channel. And we call it a bar. The shallow part of the channel is called bar. You cross the bar at that specific time. So your whole thing is timetable is affected with that. That is something to do with depth. Then another case that can happen is air draft. There are some power cables going. So you have to watch the air draft also. So sometimes it happens, not very common because nobody wants to harass so much. But it is possible you will wait for a tide to cross the bar. Then you will try to see if you take advantage of low water to go under the bridge or a power cable. Possible, but not really common. Main thing is the depth of the water and what is your draft. Next one is tidal streams are formed during the time between the high water and the low water, and they are strongest somewhere in the middle. Means 12 o'clock and 6 o'clock timing, high water and low water. 3 o'clock tidal streams will be very strong. Streams are like currents, but current definition is it goes in one direction. Streams change the direction. It is a movement of the water. So it's like somebody pushing you or somebody pulling you, something like that. Now ships, big ships are quite difficult to maneuver. You look at it, about 300-meter long ship with so much of cargo inside. It doesn't move. It moves like elephant, slowly, and then you have to turn perfectly. Otherwise, you'll hit something. To avoid all those accidents, most of the ports do berthing on twice a day, generally high water timings, where high water there is no tidal stream. Tidal stream is changing direction, so velocity is zero. So that time you do the berthing so that you reduce the chances of accidents to bare minimum. Got it? Okay or no?
Yes, sir. Now okay.
Okay, very good.
Sir,
Huh. Yes.
basically this means that the ships wait for the high tide or the low tide in order to get into the port.
Correct. They generally time it accordingly. Now what happens is you can go there and anchor and wait. Other one is you adjust your speed, save some fuel, because slower you go, you save on the fuel. That you will do sometimes in your engineering knowledge. So generally they come perfectly on time because pilot says okay you be here at 9:30. Everybody has got some allowance in pocket to make sure that safety is not breached. So 9:30 means I reach there exactly at 9:30. Okay, I adjust my speed and 9:30 pilot come. We go in so that everything is safe and sound. Got it? Hmm.
Yes, sir.
Yes, sir.
Very good. See, it's all straightforward. You have to understand the idea. What is it? Keep it simple. My ship has to go. I want to maximum advantage of every climatic condition, every natural condition, and so on. Otherwise, it will be very expensive to invest, but doesn't mean you are earning much. And generally, it happens with the poorer countries, third world countries. Cost was too high, so they had to play around with all these things. Normally when you go to developed countries, they have already taken care of all these problems, so you don't get impacted much in those countries. It's a rare thing that they will make you wait unless your ship is excessively big for the port. Hmm. I think we will stop here.